Magnetic dipole moment of a revolving electron. Okay, so in this topic we shall see how much is the magnetic dipole moment when the electron revolve around the nucleus. Okay, so let us consider this is the orbit of the electron, and let us say that this is the center of the nucleus. Suppose this electron, right, has a charge E, and this electron, let's say it is at a distance small r from the center of the nucleus, and this electron, let's say it is revolving in the anti-clockwise direction. Okay, now because electrons is moving in this case, so I will have what? A current. Let's say the current which is produced due to the motions of the electrons, the current is I, and this I is equals to charge upon time. Okay, or I can say this I is equals to charge. When I say charge, it means the charge of the electron. So the charge of the electrons, it is small e upon time. When I say time, mean it is the time period of revolution of the electron. So what is the time period of revolution? For that we denote by capital T. Or I will say I is equals to E upon, what is capital T? Okay, we know this time it is equals to, alright, distance upon velocity, isn't it? That is the formula of time period. So when the time in this case it is capital T, it means that the distance taken by the electrons to complete one revolution. So for the time period, I will write capital T, and what is the distance which is taken by these electrons to complete one revolution? That it should be the circumference of the circle, which means 2 pi r in this case. And what is the velocity? Let's say the velocity of these electrons which is moving or revolving around the nucleus, let's say it is v. So instead of t, I will write 2 pi r upon v. Or I will say I is equals to ev upon 2 pi r. Okay. So after this, I will modify this equation by multiplying and dividing it by m. So when you multiply and divide by m, then you'll get m, okay, alright, sorry, let us do it this way. So I'll name this as equation 1, because I want to determine about the magnetic dipole moment. So what is the magnetic dipole moment? The revolutions of the electrons around the nucleus, it is like the current carrying circular loop. So for the current carrying circular loop, you have seen before that the magnetic dipole moment, it is m, and this m is equals to IA. Alright, or I can say this m is equals to, instead of I, will write EV upon 2 pi r. And what is A? This A, it is the area of this circular orbit, and for this area I will write pi r square. Okay, next, the magnetic dipole moment in this case, m is equals to, now this pi with this pi will be cancelled, this r with this cancel, so you'll have just EVR upon 2 upon 2. Okay, now if you multiply the right hand side, you multiply and divide by small m, then you'll get like this. Okay, what is m? M is the mass of the electron. Okay, so here I think it's to avoid confusion, right? Because on the right hand side also we have m, on the left and the right we have m, so you may get confused. So in order to avoid confusion, let me denote the magnetic dipole moment by mu. So this is mu, this is mu, this is mu. Okay. So what is mu? Mu stands for the magnetic dipole moment of a revolving electron. Or this magnetic dipole moment mu is equals to E. Now what is this MVR? In class 11 we have learnt about it. This MVR, it is known as the angular momentum, okay, where L here is equals to how much? MVR, and it is known as the angular momentum of revolving electrons. Alright, so please note down this equation. It's very important, especially for your exam point of view, because in exams the question usually asks you to obtain the angular momentum of a revolving electron, to obtain the magnetic dipole moment of a revolving electron. So that means you have to get up to this equation. Okay, this is equation 2, so I'll name this as equation 1. So you have to get up to equation 2. Right? Okay. Now look at the directions of the magnetic dipole moment. Because this magnetic dipole moment, right, as I have already mentioned, it is a vector quantity. So if it is a vector quantity, then it should have a direction. And in vector form, I will write this mu, okay. If you write in vector with an arrow on top of this, it means this right hand side will be negative. And because we know angular momentum also is a vector quantity, so I have to put arrow on top of small n. So this negative sign here suggests that if this is the directions of the magnetic dipole moment, then the directions of the angular momentum will be opposite to m. Alright. So, okay, this is all about how to find the magnetic dipole moment of a revolving electrons.